All right. Thanks, everyone. So, again, community style talk. I'll be sharing some experience and insights around platform engineering and trying to align that with software engineering, and so that folks can get that aren't involved in platform engineering. First of all, like, what is it, right? And what do you mean by that? And then getting in and talking a little bit more about what it means, because if you're on the software engineer side of the fence, what's it like on the other side? So talk a little bit about that. Hopefully it's interesting for you. So the first thing, that was kind of strange. My name is Mark Panthofer. I work for a local consulting firm here that's been around for like 35 years, Envisia. We have been focused on, and I'm not saying this to plug Envisia, but just kind of our experience around a lot of open source style things. Okay. Oh, I think we have a. Oh, okay. All right.
So I'm just gonna attach this.
All right. So let's see, is that. Okay, so that's, you guys hear me all right? All right. Then I don't have to stand like right there. Thank you. So anyway, the reason I bring that up is we've been really focused on more open solutions as an organization for quite some time. I'm going to just, flash back like 10 years ago. My background has been kind of varied. I always kept screwing up and getting into management, and that's not my thing. So I really prefer, nothing against that, Yurik, who runs our Chicago office. It's great, and it turns out I was pretty good at it, but I love technology. So about 10 years ago at Envisia, I really wanted to get back into that track. Got involved with a company called Docker. I don't know if some people have heard of it, for the running containers on your laptop. So anyways, was able to get involved with them early on and really became a adjunct solution architect, essentially working with their team. They had just a brilliant group of folks, and it was just an honor to work with them. And then was approached by Pack Publishing to kind of capture that in mastering Docker Enterprise Edition, which I wrote back 4 or 5 years ago. But these days, so getting involved with containers and Docker and Kubernetes brought me into an environment that was really interesting, because we'd be, hey, can you help us deploy our applications with Kubernetes? And then we'd go out to their cloud setting, and they had public endpoints, and everything was a nightmare. And then we'd spend up a bunch of time with their networking teams and their security teams. And so we just had to all of a sudden get really good at cloud architecture as well. So we started to do that and putting those pieces together, and really started getting into, well, then how do you deploy this with infrastructure as code and DevOps at large? Then I worked as an advisor to Milwaukee School of Engineering. Actually, I graduated from there, as an advisor for DevOps, and also in the software engineering group. But the main thing I wanted to probably focus on here, obviously I work with some great customers. That's just kind of a short list of recent folks. But it was in the center of the slide for the DevOps Standards Committee. So that is probably the most interesting background that I bring to the talk today, because in that environment, it's not just like us working with clients, it's us collaborating with some of the top organizations, like everything from aerospace down to like startups, and talking about what's going on in the world, and that's particularly around DevOps. And so that really gives me a foundation, at least from my perspective, to present my ideas and talk through this. And also I'm interested in starting conversation around this. So some of it's a little semantic, as you'll see. So to begin with, I like to talk a little bit about this idea of cloud native platform engineering. That is a mouthful, but if you separate them, things tip over. If you don't think about them together at the highest level. And so when we kind of break that down, we think about DevOps and I'll talk about cloud native, and I think hopefully everybody's like really familiar and can jump in if they have thoughts on that. But and then getting into the concept of platform engineering and how does all this stuff work together, and how does it come together? So the first bit really around cloud native. So the part that I really like about the cloud native piece is, and this related to us as at Invisio, where I've worked for quite some time, that we're putting the community in charge of where technology goes. We're not leaving it, and all respect to Google and everyone else for trying to do the right thing, but we also want more of a community to drive the future of cloud native technologies, right? And so through the CNCF, and really starting to come up with more essentially environments that we can take well-engineered, loosely coupled systems and build those things and bring them to life in a non-proprietary sort of way. And so from a cloud native perspective, the whole mindset, again, this is a little bit of a culture thing, right? Reducing toil, focusing on building these great systems that scale and that we can deploy and maintain very easily. But I think the real part there is democratize the state-of-art patterns and take that out. So anybody want to shout out like maybe any cloud native technologies that we use that we can use multi-cloud pretty easily? What's it? Terraform, yeah, with different providers, absolutely. And what about deploying applications? Everybody loves PowerShell. Yeah, that works. If you're in that Windows thing, which again feels a little Microsofty, but they're lovely people. Yeah. Bash, but think about more like runtime deployment.
Oh, sorry, I was thinking more VMs that were.
Yeah. So what's beyond VMs? What do you think I'm thinking? The guy who wrote the Docker book. Kubernetes, right? So what we're trying to do is essentially come up with a fact as developers. I build my applications. I can run them locally in the same way or very, very similarly to how they're going to actually run in production. I can run Kubernetes on my development machine. Again, I may not be able to load 150 microservices and test it, and there's ways and strategies around that, but I'm able to do that and not just run it on my laptop, but run it with GKE, run it with Azure Kubernetes Service, Elastic Kubernetes, EKS, et cetera, which is funny. I work with those every day, and my brain is another thing. So once you do that, it's not like you're totally stuck on a particular platform. It gives those opportunities. And I think that is probably like one of the more grand successes when we think about cloud native technology. It's also a little frustrating from a platform perspective because it's a very, very vibrant community. What does that mean? Lots of contributions. What does a lot of contributions mean? Yeah, a lot of updates. Right? You've got, and so people, are like, wait a minute, we just updated our cluster. Yeah, well, that was like last month, right? So there's a lot of things there that are, kind of the good and good, bad, and the ugly. But anyway, so, cloud nativeness stuff, I won't, get into a ton of this. I talked a little bit about containerization and then dynamic orchestration, really, really important parts of that. But another big part really has to do with declarative APIs. So this is something that, Kubernetes has been around a while, but this has been emerging where Kubernetes has declarative APIs in the sense of deployment. So I'll talk a little bit about that in the IAC, a little more of a breakdown, imperative to declarative. But it's a very, very powerful construct that we use not only to deploy, to define the desired state of a deployment, but also for infrastructure. And it was mentioned Terraform before as a great example of, I know what I own. I know what I created. Is it still the same way it was? And how do you want it now? And so we'll talk a little bit more about that in a bit. But this stuff is all every single one of these points here is really important. Even stuff like service mesh, you'll say, well, I'm not using Istio, right? But on the other hand, if you're using Kubernetes with standard straight up DNS, you're already finding a way to locate your other services, right? So these things are just kind of baked in and part of that ecosystem. So that's kind of the cloud native part. I think everybody good on that, or understand CNCF, go out, look at their landscape, pick one of the 5,000 icons and run. That's what I tell people. No? The other part really just getting into DevOps itself. So how many folks here have read the Phoenix Project? A handful? Okay. If you haven't, even if you're not like wild about DevOps at this point in thinking, read it. So if you've worked in IT or as an engineer for any period of time, you know the characters in this book. You've lived the Phoenix Project. Phoenix Project, a fictional account of an organization going through a big struggle to release software that's critical to the survival of their business. And so we all know, we can relate to people on there. The DevOps Handbook is the next thing I would strongly recommend from there, and that's the non-fictional version of how to DevOps, right? So it starts to give you ideas and thoughts about how to move forward with kind of what we refer to as the DevOps way, which I'll talk about in a second. And the final one on the DevOps front is Accelerate. So Accelerate is what happens to organizations that have adopted and jumped in with DevOps techniques. And the numbers are pretty significant. So the next bit, talk a little bit, and I'm going to pull some of these together because they're fairly interwoven. But when we look at the idea, I'm referring to vanilla platform engineering. So when we've seen this term come up, sometimes we just hear about platform teams. How many folks in here do their organizations have a platform team? Okay. All right. And then at the end, you get to tell me if it lines up at all. So sometimes, how about a DevOps team? Yeah, that's just a little bit more prevalent and generally see that. And sometimes the platform team is just renamed the DevOps team. And so it's like a little rebranding effort. Well, you're feeling good, you're a platform engineer. You were a DevOps engineer last week. So we'll talk a little bit about some subtleties there that I think are sort of important. But the basic concept is pretty straightforward, that it has emerged over time that development teams, as ambitious as they are about wanting to shift left, find out that PagerDuty sucks, okay? And so not only that, the cognitive load of understanding everything is fun at first, but keeping up with all that and also being able to release features in a way that keeps your business moving forward is very challenging. So the idea of the platform team is essentially that it's there to support application development teams, to help get their application essentially into production, if you think about it that way. Giving you the tools you need, the platforms you need, and there are ways of doing that that are better than others, some of them, and that's when I'm going to touch on some other points here. And then the key customers, right? So there's multiple constituents when you have a platform team or platform engineering group. So you have the application development team. That's the key one. That's the one that you want to collaborate very closely with. If they fail, you fail, right? And they're the ones that you need to push them forward. You're the team behind getting them, not blocking them. So one other thing I'm going to point out, in all of my thinking about all this stuff, we move from with these shared groups from silos of governance to teams of enablement. So platform engineering is to enable teams to get things in production, not throw things in their way. They're not the enterprise architecture team that just says no, no, no. Right? No, just kidding. Some platform engineering teams are more enabling than others. That's really important. But they also need, along the way, so that the application teams don't run into bumps, they have to support security and compliance. It's got to be baked in, so that the development team doesn't have to think too much about it. if you're doing this the right way. And then obviously operations, sometimes that comes through kind of an SRE sort of function to make sure that things are healthy and functioning correctly. And then finally, the business stakeholders. This one gets left off sometimes. How much does it cost to run this platform of yours, right? So that's a consideration you need to think about up front. And so anyway, so that's kind of the vanilla platform engineering. So those are some concepts there. So now when we start to bring it together, one thing that has really changed my thinking, and I've seen affect organizations and begin to affect organizations, is really the concept around team topologies. How many people are familiar with team topologies? Yeah, there's not many folks, right? So, and this is, it's a crying shame, right? So, and the reason is, the most difficult thing with platform engineering has nothing to do with technology. It has to do with people. It has to do with culture. It has to do with structures within organizations. And team topologies fundamentally gets you out of the mindset. I mean, if I were going to sum it up in a implementation that works well or thought, I would say stop reorganizing and thinking about the structure of your business. Start thinking about your behavior. And that's what team topologies focuses on. So you have areas, right, that you belong to in terms of teams, but that collaboration and interaction. So the reason this is so important, that over time is, I'm not gonna get, this could be a whole nother talk, right? But over time, when you have this flow of change, stream-aligned teams, these are the folks that are out there delivering features to the business, right? When they go out to deploy their first application, they may have very tight collaboration. In other words, people from that platform team joining their team in stand-ups and helping hit milestones to keep that team moving, because they may be bringing on some new things into their environment or coming onto a new environment, or it's a brand new environment altogether. So the platform team is making it up as they go along. Their thought is to get this team into production in a safe, secure way, but then they also have to take those artifacts back so that when they work with the next team, they can just facilitate. So now you share the artifacts, you work with those teams. So instead of working 40 hours a week with them, now you're working 16, getting on calls, walking through and doing step by step. You get good at that, then guess what you can do? You can start putting it in a portal as a service. But don't do it the other way around, because it won't work, right? If you try to go to an IDP and you say, oh, we're gonna build it and everyone's gonna come. Anyone ever see that work for real? I'm looking, I'm counting every head in this room because I haven't. So, all right, good. So that's it. So again, the idea is that you really want to, you have your various enablement teams, and they either join kind of from a collaborative, facilitating, or as a service, and that's a progression that has to happen over time. That's a really key idea when you're building out your platform engineering team and you're trying to establish services. You don't do it in a vacuum. You're only as successful as those teams. And by the way, your first team might be very different than the teams that come behind it, because the first teams that volunteer and step up to move forward on these tend to be more motivated than the rest of the organization. So think about that. That's one of my lessons learned. I've made that mistake maybe once. So what does that mean? So what it means, in essence, is that we pull this together. When I think about cloud native platform engineering, I'm thinking about DevOps as a key component, really around process and culture. So that brings to us some of those ideas of flow, feedback, continuous improvement, and generative culture. So how many folks have heard of generative culture? If you haven't been the Gene Kim fan with some of the DevOps movement stuff, maybe you're not quite as familiar with it. But very high level identification was really 3 types of cultures and organizations. And it's not like your organization's all one or the other. Depending on managers and groups, they can vary quite a bit. But when you think about that, there is the generative culture, and that's a learning culture. It's safe to try new things. Obviously, you're working within some guardrails and some risk management, but you feel good about doing this. You're contributing. You feel a part of it. Then the next not so great is more bureaucratic. Bureaucratic is, hey, we pretend to get along, but silos don't talk to each other. And silos are fiefdoms, and we win or they win. It's not we win together kind of thing. Unfortunately, it tends to happen that way. And the last one is kind of the, luckily we don't see quite as much of this anymore, but pathological. Pathological cultures are basically shoot the messenger. Hey, wait a minute, if we don't change this code, we're gonna have a serious problem. You know, you go work in the mailroom, you're out of here, kind of thing, right? That would be pathological. It's not healthy, and nobody wants to work there, right? So when we talk about DevOps from the culture part, we're talking definitely about a generative culture. The part about team topology is I already talked a little bit about that. So it's not just the structure of your organization. Don't just focus on that, because that leads to bureaucratic culture. Okay, so what you want to do is say, how do we play together? Yeah, I belong to this team. I have responsibility as a platform of coming up with standard ways for us to do some things, but I do that by interacting with the teams around me and enabling them, right? And then finally, the cloud native technology. So when you're starting, so sometimes I see folks just dive in. We're just going to go to Kubernetes. Okay, good luck there. And they don't have the other components in place. It's not that you won't be successful, it's just going to be a lot harder to really achieve and achieve at a much higher level. So definitely look at these things coming together, and particularly as you build that capability out. And this isn't something, you don't build one of these at a time. You kind of lift the boat, right, across the board, and you think about it intentionally as you improve your capabilities around platform engineering capabilities. So, and of course, platform engineering is real because Gartner says so, right? So anyway, this is one of their public posts about some things. It's a number 4 technology trend that they were putting out there for 2024. And the thing I'd like to be careful about is this was brought up to me in the context of Developer Portal. It's kind of, again, running with the new shiny. Backstage IO is cool, don't get me wrong. But if you go through that route and build it and they will come, you might have issues. You need to have that relationship with those teams as a platform team. You have to be able to develop those relationships, and you have to be able to develop assets that they're going to find easier to use than starting from scratch. And if you don't, they won't. Or they will start from scratch and not use your stuff, right? And now you've got all kinds of issues. So it's a big thing. So the other part about the cloud native platform engineering is really getting into the agility that focuses on the user. So again, we're allowing, and if you think about the user, in this case, might be your application team, but then your application team can focus on the end user they're writing features for. This shifts your whole organization, right? And it's been shown that organizations that do this well outperform their peers by 40%. All right, and by the way, those of us who work there are 20% happier. I don't know what that means. Maybe someone could explain that to me later. All right, so we're talking about kind of the platform engineering role a little bit more, specifically personally, if I'm a person involved in that, right? So the new rock stars of DevOps, is that what this platform engineering thing is? And this is just for people that can't handle dealing with people. So they're going to deal with machines instead. And so no, that's not really it. But when we look, I'm going to kind of go through a couple things here. And just a time check. So we have till 11, is that right? Okay. 11:15? Yeah, because we started later. Yes, okay. Thank you. I was having a stroke, but that's right. Didn't show, did it? All right, so anyway, the platform engineering. I heard some discussion. We talked about Terraform before. So when you're looking at that, the first 3, I think if for a developer and a software engineer, those are kind of still a little bit in your wheelhouse, right? Or you've played around with them, or you've done some things, right? And the Terraform, even if you're doing like a local stack thing or you're doing something very simple to just kind of learn it, is kind of interesting just to understand a little bit more about declarative programming in that sense. But the first three I think are fairly straightforward. It's the fourth. Well, I didn't bold the last one for some reason, and I stopped typing. Anybody know what happened there? If you do, let me know. So the cloud services. This is a really key part when you start to get into this realm. And I explained it a little bit, how it got pulled in kind of from the containers and Kubernetes side of things. You start to learn a lot about cloud architecture. You start to learn a lot about networking. Now these, I think, for developers and software engineers in general, are the Achilles heel. And when I'm working with an app team and I bring up networking, people need to get coffee. Wait, look, my phone, check my watch. So that's kind of a key focus, I would say, in terms of from a skill gap perspective that you see out of the box. And networking is not that scary. No one's ever been eaten by a network that I'm aware of. Wait a minute. We've got 2 survivors over here. We've got to go. It tried to. I know it. So anyway, so that, and the whole thing really kind of coming into there is also the idea of understanding variations between different providers. Okay, so GCP versus Azure versus AWS, but then also coming up with some more standardized structures, back to that cloud native thing. Start thinking about hub and spoke. How do I implement this? What are some good patterns that I can do to apply across these different environments? Pretty important bit, and every one of the providers will try to kind of gently push you down a particular path. And sometimes that's good, but there's only one thing that I have learned when it comes to choosing the cloud provider. And by the way, I love GCP, so everybody good? All right. But the one thing I've learned is whenever someone has made an absolute statement that we're all in on X, whether it's GCP, I've heard it with AWS more than once, and we've helped those people move to GCP, by the way, within a year. We're all in on AWS, and we're not going anywhere. So we're using every one of their opinionated services, and we're just wiring it up like big Lego assembly. Versus, wait, maybe we should be building it in a more cloud native way and running things more from a containerized, kind of platform perspective. And again, lo and behold, we've helped some of those organizations within a year's time move to GCP, as an example. So point is, no matter what anybody tells you, there is no forever, and things could change. So the other side of that, I'm going to say, with a little bit of caution, is don't spend your entire life trying to engineer everything, so no matter what happens, it's a zero, effort migration, because if you get to that level, you way over-engineered things. And we like to do it. I mean, I think one of our common expressions I've heard many times, why would you just engineer it when you can over-engineer it, right? But that's something you need to be careful as well. But trying to come up with, like in the cloud environment, like hub and spoke architecture, sticks it to some basic values. Consider using things that are not necessarily just a part of that cloud ecosystem, like Cloudflare, for instance. We end up using a lot of that on the edge and bringing things in. And all of the cloud environments have their own edge computing environments, and they're all great. But sometimes it's nice to have one that is independent of whatever your backend is. In terms of collaboration, so contrary to the person that doesn't want to deal with people sort of comment, actually platform engineers better be really good at working with people. And I'm going to show kind of a diagram toward the end of this, which is going to give you a little bit more of a feel for like how this stuff manifests itself and all the constituents that you work with in the role on a platform engineering team. So the first thing is really kind of that cross collaboration within the whole development life cycle. But it goes beyond that. I'm not just deploying a piece of code, I'm defining platforms. Okay, and in those platforms, they have components, they have security, compliance, operations, things that we have to pay attention to. The other part is thinking about the enablement. The slide talks a little bit about like self-service tools, but the reality is the first sort of line of engagement is you. It's you showing up on a call with a team who needs to deploy to a new environment they've never used before. And maybe, by the way, the platform team has never deployed anything to either. So now you're embarking on this adventure together, right? To get this done and do it in a good way. So you're there as an enabler. You're not there as a cop. You're not there to throw roadblocks in front of anybody. Your way is to figure out how to make it happen and do it in a way that falls within your compliance and security guidelines, right? So, and by the way, that can be challenging. When you start talking about problem solving and being really creative around it, there's situations you'll run into where you're like, if we just do this, we know we have a pretty tight, and it might be hard to do that, but that's, for instance, like private networking, okay? If I'm not exposing any endpoints and I allow no exfiltration, I know what's going on in this environment, period. Because everything's coming through a specific point, right? That's where hub and spoke is awesome, right? Because the hub is going to manage that for you. But there's strategies that you can use that make that easier. But you got to stick to them, right? As soon as you start doing that, well, for this one, maybe we'll allow, don't do it, right? And so, and that's just like technical debt that we have when we're doing development. It's like, well, we've got this new architectural pattern, but this one last time I could just squeeze in this cruddy old way we used to do it, right? So same kind of things exist there in terms of the challenges and temptations, if you will. Innovation. So one thing I will say about platform engineering, if you don't like learning new things, first of all, you probably shouldn't be in tech, okay? But you definitely shouldn't be in platform engineering. So of those technologies that we showed before around pipelines, so GitHub Enterprise, Azure DevOps, they're all evolving quickly. Then we have the actual cloud environments that are changing all the time. And there's always new things coming out. Then inside of those environments, you're running like Kubernetes, cloud native stuff, always changing. And they're always, and some of these are big improvements and they're big, changes. So when it comes to innovation, coming up with clever ways of being able to pull that stuff in, and as I really like to talk about is like create bubble wrap so that a team can engage with your platform, but also if they need to, you can expose what they need as long as it's done in a controlled, by that I mean version control, automated deployment pipelines, et cetera. You can expose them. They can go in and tune the horizontal and vertical if they want, but you now own that, okay? The platform team gave you the one that works out of the box and things like that, and we'll support that. And if you need to, for business reasons, to break the glass, go break the glass. If it's something we're gonna have to do more widely, platform engineering can come back and help you with that, right? But so you don't wanna have black box environments. In other words, where it's dark inside, no one can see. It's just I just give this to you, and I turn it on and everything works and you have no idea what's going on inside. That's not what you want to achieve. So, and I would also say, from a collaboration perspective, probably an interesting footnote is to have all of your modules, all your code that you're using, like Terraform modules, et cetera, all part of in the open repo, okay? Anybody can come from a dev team and say, I would like to enable a particular feature in a service using Terraform, merge request, pull request, and you should be able to take a look at it, evaluate it, and get out of the way if you can, okay? So that was another thing. So it has to be a really, so the reverse of this kind of closed box is, playing an open hand, which gives people more opportunity to participate. And by the way, you're not gonna have a ton, from the dev team, but you will get a few folks that will go crazy, which is great, right? And they become great contributors to that. So yes, we bring you in slowly. Yes, so next thing you know, they're on the platform team. Whoa, how'd that happen? All right, so yeah, and the last part is like this thinking about the platform as a service or a product. So that's what you want to get to. Remember, you can't do the build it and they will come. You need experience working with actual application teams, assisting them, enabling them, and you need more than one. Sorry, because the first one will be one set of data points. The next team may interact very differently, have different skill sets, backgrounds, et cetera, and you want to make sure that you're accommodating that as you move this from just a set of artifacts, forming them together into a solution that can actually be to the point where it's a parameterized solution that you can deploy from a catalog. All right, but you want to be thinking about it in terms of services. You want to have boundaries around it. You want to have different releases. Absolutely, by the way, rewinding to the shared repositories that you might have for code or Terraform, et cetera, that you're using. Semantic versioning always, and tagging, right? Because you want people to be able to move at different rates, right? Within a certain degree. So that was one thing I just wanted to throw in there, sorry. Otherwise you get a very big mess. Otherwise you're forcing people to upgrade, and they're not gonna like that when it's not convenient for them to do it, right? So we don't wanna be there. Problem solving, again, my favorite one is number 2. My pod is stuck, it won't deploy. Crash back off loop, right? So again, there's a whole bunch of things from the infrastructure side of things and problem solving and engineering, really, that is born out of the set of problems. Then there's the idea of, again, from just releasing and then rollback recovery for environments. Hey, something went wrong with my deployment, and we're down, this is bad, so those are the ones you're going to get pulled into and dive in, and sometimes those are exciting for a very short period of time, as long as it's not 2 a.m. And then the and again, any performance bottlenecks, and this isn't just like my app's running slow, it's like, why does it take me 3 weeks to deploy to production? That's a bottleneck. Right? So those things, looking really at constraints within your flow and understanding that and improving those as well. So have I scared everybody away enough from platform engineering? Okay, good. Because I'm trying to bring people in, but I want it to be real, right? So in a day in the life kind of thing, and then I'm going to bring up a picture for some discussion here, kind of to really kind of round things off. But so. Infrastructure, design, deployment, that is sometimes surprising to people. They sometimes still think it's DevOps, and don't you run Jenkins? Aren't you guys the Jenkins people? And so like in a platform team, first of all, most of us aren't running Jenkins anymore, but nothing wrong with that. But it's one small part, right, of what that team does. That happens to be the developer's platform, right, for source code control, and deployment, automation, builds, et cetera. The pipeline management, again, it could be a combination of pipelines and infrastructure. It could be, hey, my private deployment agent's offline. What's going on there, right? So things like that, or just basic troubleshooting that's beyond the scope of a team, being able to do that. The security implementation, that's not something you're doing directly with a team. That's generally instrumentation in the platform itself. And also that could be something like making sure that certain ports are never utilized, making sure we never have public endpoints, and things like that. But then also from a compliance perspective, it could be policy as code. So you could be writing Rego, which is so much fun, and deploying that into your source code control and deploying it into your environments so that anytime something gets deployed, it's checking policies. Okay, and different providers have different ways of doing that. But that's another area that's actually really cool, because again, you can give teams a lot of flexibility if I know that I have basically policy monitoring going on in their environment. They can do all they want within the guardrails, so to speak, right? But as soon as they try to do something outside the guardrails, it's going to shut them down. And not shut down their application. It won't let them create it, okay? Not going to do something mean, like pull the rug out from underneath you to your production. That would be not nice. And obviously the monitoring and optimization as well. And sometimes that's, by the way, I hate to say it, but is mostly around financial optimization. It's like, why did we just get this bill? You know, so anyway, you want to have obviously more real-time kind of things going on, so you don't worry about that bill. So now I'm going to show you a little something that we've had enough of these, boring walls of text slides with Grok-generated images. So, but this one is an actual human-generated image, and I was the human that was involved in said process. So what I wanted to do is just kind of walk through a little bit, right? So platform engineering area, right? Sounds pretty straight up. It's like, hey, so, I'm out in GitHub. It's where I live. It's my indigenous kind of environment, native environment. And so I'm comfortable there, et cetera, but what do I do? What kind of things do I do there? Well, a lot of things, right? So to begin with, you establish the actual platforms themselves using infrastructure as code. By the way, some of that should, if you're following practices, should include creating repos. The creation of repos themselves comes from a repos, okay, with infrastructure as code. And you want to do that so you have consistent policy application and things like that. And you make it easy and quick to be able to create those in a uniform way. But that also means creates your environment, right? So basically like an application development and prod environment, kind of this light blue and the darker blue box here. And that's where my app teams are going to deploy their stuff. Okay, so how does that happen? Well, guess what? Cloud architecture, compliance, a bunch of other contingent stakeholders provide you with specifications. We capture those specifications with infrastructure as code, generally speaking, and pipelines, generally layered pipelines, rather than having one big, ugly, monolithic kind of a thing. Kind of migrating maybe a little bit past the Terra grunt in more of a layered environment. So anyway, defining those, building out those modules, infrastructure as code, and then using pipelines to actually do that blue dotty thing there to establish and build out those resources for each of those, okay? So meanwhile, application developers, which I think we have many in the room. This is DevFest. Everybody should be festing in the dev. And so you're over here writing code, doing things. Maybe you have an SRE attached with you as well, trying to show you the way. And you're putting your application code out here. And the platform team, if they provided you a good platform, so this is going to be a litmus test, right? So one of the things I talk about is if a platform team delivers you a Kubernetes cluster and says there, they failed. That's an enabler. It's not a platform. What you should have, right, is something that has working examples for how, and thought through, how do I handle persistence? How do I handle single sign-on? How am I handling end-to-end encryption? I don't want to figure that out as a dev team, right? It would be like ordering a new Tesla and having it show up in the curb in like 50 boxes. Yep, there you go, right? So that wouldn't be cool, especially the high voltage battery thing would scare me. But a regular car I'd be more comfortable with, just for what that's worth. So the point is you deliver that platform ready to go. There's a pipeline. Somebody should be able to actually clone a repo, make a modification, push it, and it should end up in their dev cluster, running with all the parts there, okay? That's a platform, okay, in case folks are wondering. So in terms of my definition, so these developers already, right out of the box, can clone, add their stuff, go through, deploy it, goes through the same automation engine essentially, and gets deployed. All these folks, when their agents are deployed as a part of the IAC, their dashboards light up with all the instrumentation that you put out there. So the platform engineering team becomes a super important focal point. And my favorite part about it is you get to learn about everything. You're going to know about networking because guess what? Nobody's logging into a Cisco switch anymore. You're going into a Terraform file, right? And you're modifying a CIDR, and you're applying or planning and applying it. So it changes everything. So you get to start understand about networking and all the other aspects around compute and storage, and then other things that you put on top, like Kubernetes as an example, and different types of databases, et cetera. So it's probably from that perspective of learning for folks who really like to get into a broad range of things, but you still have experts specifying some things about those, so it's not like you're floating on your own. Feeling dangerous, right? It's a pretty cool job. So that's most of what I wanted to talk about. I had some stuff with IAC here. I'm not going to get into a whole bunch of things here. Only thing I would talk about is that this idea I promised earlier, imperative versus declarative. So imperative is scripting. We've all written scripts. Sometimes our coding language is scripting. That's an imperative way. And if I try to run the same script against an environment twice, likely to blow up the second time, right? And that already exists, or things like that. Declarative is essentially, tell me how you want it in the end, right? Define your desired state, and then it goes and figures out all of the things it needs to do behind the scenes, okay? That is, especially when you're dealing with complex cloud infrastructure, that is the only way to go. And so very, very powerful and an important concept. I was gonna see if there's anything else. So there's a fun little Terraform file, apply. I do have a point to this. So you could be using, on the left, you see like there's the console in here. I mean, this is what Terraform gives you out of the box, right? But what you need to be doing is doing this inside of a pipeline, okay? So you need to be grabbing that Terraform configuration source code. You need to be grabbing the endpoints and managing them and taking them down the path. So once you're done, you push the apply button, you get one of these. Okay, this is just a basic hub and spoke that happens to be an Azure flavored architecture. But can you imagine, so an average environment would have several hundred resources with thousands of configuration points. Do you want to be clicking through a portal? Remembering what the last person did? Or wait, when we did that 3 months ago, now I got to do it for another team, right? So you don't want to be there. So that is it. I think we ran up against the little dashes are there. That's not good, is it?
Great.
Okay.
That was impressive.
All right. Well, wanted to have more time for questions. So I'll be around if you have any questions. We're out of time, but I'd be glad to answer any questions that you have. And thanks. Appreciate it. Yeah.